In this video, you will learn how to make this cool effect. I'm gonna cover many things. Little tips and tricks are thrown here and there, so watch the whole thing and don't miss anything. Let's get started. One major problem I found in Godot is its emission. When the object gets small on the screen, it stops glowing. To tackle the problem, we can use Billboard. So let's add a new node 3D and a mesh instance 3D as its child. Add sphere as mesh and make it nice and small. Add a material, turn on emission, and set the energy multiplier to 1000. You need to have a world environment node in your scene and turn its glow on, or it won't work. Pause the video and copy my glow settings. Let's save the scene and put everything in the middle. Rename the mesh instance 3D to light mesh. And now let's add a billboard to make the emission persist even in long distances. Add a new mesh instance 3D and choose quad as the mesh. Add a new standard material. Under the albedo section, let's generate a gradient texture. Make sure the circle doesn't go out of the texture region. Enable billboard and we have it. Now we need to navigate to the transparency section and change blend mode to add. Let's make it bigger. And it doesn't get bigger because we need to enable keep scale under the billboard section. It's working, but it's also receiving shadows. To fix the problem, under the shading section, set the shading mode to unshaded. This makes the material only use the albedo color. No lighting and shadowing will be processed. I've got an emergency. Subscribe and hit the like button till I come back. Here are some other settings which in some occasions can help you make materials more efficient. You can change the diffuse mode to Lambert, which ignores roughness data, and you can disable the specular mode and ambient light. Under the shadow section, receive shadows option can be disabled too. Keep it in mind that none of these settings are necessary in our case because we have set the shading mode to unshaded. There is one more issue to address. The light disk goes behind objects and that's not how a light disk looks in real nature. To solve the problem, simply check the node depth test under the transparency section. Now it's time to hide it when it goes behind obstacles. We need to use RayCasting and Godot makes it so easy. Simply add a RayCast 3D node. Let's name it RayCast. For my specific project, I need to enable layer 1 and layer 2 collision masks. These are the layers the RayCast collides with. Attach a script to the root node and get a reference to the RayCast. We need to set the RayCast target position to the position of the currently active camera. This is how to get access to the current camera. To make the code more elegant, I get a reference to it at the top and name it cam. Anything related to physics must be inside physics process function. Using toLocal function, I convert the camera global position to the local space of the new light object, or it won't work properly. Now it's time to hide the light disk when it goes behind an obstacle. Now let's make it more realistic by adding some fade in and fade out animations. But before that, to avoid this annoying warning, simply rename delta to underline delta and it won't be shown again. Godot animation system has two major nodes, animation player and animation tree. Animation player is the node where you set up your animation track. Simply add the animation player and note that at the bottom I'm in the animation tab. Click on animation and choose new. Each animation can have many tracks to handle different things. If you don't see the key icon next to the properties inside the inspector, simply click on the animation player node and select the light disk object again. Clicking on the key will add a track to the current animation inside the animation player. Set the animation duration to 0.2 seconds. Ctrl plus middle mouse wheel zooms in and out. Go to the last frame, make it black and click on the key again. Let's play it. Cool. Now add another animation and name it fade in. Repeat the process but the colors should be reversed. In order to be able to use these animation tracks effectively, we need to add the animation tree node. Assign the animation player to the animation tree and choose animation node blend tree as the tree root. Here we can set up animation logic. Add two animation track nodes, one for fade in and one for fade out. Then add a transition node. Name it is_hidden. Inside the input section in the inspector, add two elements, true and false. So if the transition input is true, it means the object is hidden. Hence we need to connect the fade out animation to the true input. If it's false, the fade in animation should play. Connect the transition output to the output node. Don't forget to activate the animation tree node or it won't work. Back to coding. Instead of just hiding the mesh, we are gonna use animation tree to control the animation. This is how to set the isHidden parameter to either true or false. If you think the animation is too slow, simply change the duration in the animation player. If your animation keeps looping, you must disable looping inside the animation player. So it's not just an option for previewing the animation, it's how the animation is gonna look in the actual game. Now we need to play the same animation when the object goes outside the screen. And again, Godot has a handy node to check if something is on the screen or not. Add a visible on-screen notifier 3D node. Make sure you don't add the enabler one or it won't work. Name it screen check and navigate to the node tab right next to the inspector tab to access the node signals. Connect screen entered and screen exited signals to the root node. We want the light to fade in when it enters and fade out when it exists. Run the game and it doesn't work. The reason is that the ray collision detector works even when the light is outside the screen and it prevents the animations to play properly. So let's wrap the if statement inside another one and it still doesn't work. That's because you need to make the bounding box of the screen check smaller. Depending on the size of your light mesh, you may need to tweak these numbers. It's so simple, isn't it? Now we are gonna do the exciting stuff. We first need textures. Add a new mesh insert 3D and name it Light Rays 1. Do what you did for the light disk. Let's use the sparkles texture to better see what is going on. Increase the scale to 5 and disable the light disk for a second. It's working but it has no animation, so navigate to the animation player and add the necessary animations for the new material. As you see, when I try to change the color it doesn't work, and the reason is that the animation tree node is active and is preventing us from changing the color. Deactivate it for a second. Reactivate the animation tree and the sparkles are fading too. Now here's the thing. This kind of quantum lighting artifacts don't get smaller when the distance is increased. If you don't believe me, go to the roof of your house at night, look at distant lights and half close your eyes. Believe it or not, I spend a lot of time making a manual mechanism to keep the object maintain its size on the screen as the distance increases. Then I noticed that Godot material has this feature already built in. Navigate to the transform tab and turn on fixed size. We need to readjust the scales though. To make it more realistic, I wanna rotate it as it moves horizontally across the screen. Back to the roof, my investigation shows that when you move your head to the left, the lighting artifacts rotate clockwise. But there's a problem. When you enable Billboard in the material, you can't rotate the object anymore. So we need to manually make it face the player in the code. Fortunately, it's just one line of code. Put it inside process function and disable Billboard in the material. It doesn't seem to be working. Inside the material transparency section, change the cull mode to front. And it's working. We should now make the object rotate depending on its X position on the screen. This line of code must be below the lookat function or it won't work properly. Transform basis z is equivalent to the local z axis in the editor. We must use the normalized version here or it won't work. Let's have a look. It's indeed working, but it's way too much strong. Let's divide the screen position by some number to make the effect subtler. Let's add another light ray and use a different texture to make it look cooler. You need to make the material unique. Don't forget to set up the animations and adjust the scale. Change the division factor to make it rotate at a different rate. This makes the effect more realistic. Let's give the light mesh and light disk a blue tint. Don't forget to enable light disk. The light disk color needs to be adjusted in the animation player because we have keyframed it to a white color. And this is it. I hope you enjoyed the tutorial and learned new things today. Thank you for watching and stay tuned for the next tutorials.